All right, so back to leaf cutter ants. So ants form one of the most sophisticated colonies after human beings um, because of the way it's structured in a way. Because the way ants structure work, it's very distributed, and then what they have is a queen ant that's responsible for to generate offsprings, and that's all she does. She doesn't have a lot of control over the colonies. It's mostly each individual ant have a certain responsibilities, and they follow a certain kind of rules, and then that's how they get food as well. And what's also special about ants is these leaves that they cut and probably store it somewhere. They don't actually eat these leaves right away. They actually harvest it and then they eat it later on. So they're actually like a farmer kind of way. And then we can learn a lot from nature. This was just an example of how ants use some form of distributed kind of systems to make their way in this planet and to survive, even though they don't have any knowledge. That's what I say. But um, they're something that we can learn a lot of things from, and I believe the Bitcoin network shares a lot of things about what ants do in their colonies, and we can talk a lot more about this. And this is actually not my analogy. This was from a book called Mastering Bitcoin. We highly recommend you guys to read it if you're interested in Bitcoin, by Andres. I have no idea what his last name is, but that's his first name. And then that's what he talks about at the beginning of the book. So the poster is actually leaf cutter ants. So starting forward, we'll be going over some philosophies of why we're doing this and what makes this such a special thing to do. Like what makes cryptocurrency so special, what makes open source so special. Everything is related into a spectrum that is very conceivable. So this is a code that I found on Twitter a couple of days ago, or like few weeks ago, I believe, and it really stuck to me. And then this is kind of the motivation of why Bitcoin exists, why some of the open source project is, why Bitcoin is open sourced in first place as well, and what is the function of open source at all. So this code goes, there has never been a government that didn't sooner or later try to reduce the freedom of its subjects. Subjects means obviously citizens, and gain more control over them, and therefore will never be. Therefore, instead of trying to convince our current government not to try, we will develop a technology that will make it impossible for the government to succeed. And this is not like a war code. We're not waging war against anyone. This is just a simple form of resistance about not complying with the system, because the system has done far more loss than gains. We haven't gone as much gains, and there has been a significant amount of loss. So to change that, it's not just a suggestion box that you're putting your suggestions in and then hopefully waiting for it to change. You're actually taking actions to change those. And that is a system like blockchain. That is a system like Bitcoin. That is why it exists. It is to challenge the system, and that is what I like about it so much. And it just stood out to me, so just put it here. So that's our philosophy. We're trying to be like some sort of resistance over the existing system, because it is flawed in different ways, and hopefully we're trying to strive for something better. So the second thing, open source. Now, having said that, we'll get into what open source is. Open source is ultimately just a software that is open and out to the public. There needs to be 3 criteria for it to be an open source software. There's many, but these 3 are the main ones. It needs to be freely available to public, so that anyone in any place of the world can go in and check out the code base, check out what the project is about, and check out the code base or whatever it is. Second of all, there has to be software and modifications should be distributed across the network, meaning anyone should be freely open to any kind of modifications, because everyone should be represented pretty much equally. And then lastly, software and license can be freely redistributed, basically meaning that everyone can have a copy of it. So even if someone doesn't have a copy of it, everyone else can redistribute those now. the specific software and then can just run it in their machines pretty easily. So in a nutshell, it is a freedom to share, modify, and study the code base. That is what the premises of open source development is. The software is open source. It has to be free to share, free to modify, and free to study. So those are our kind of understanding of open source. Now, of course, like everything else in this world, there are some advantages and disadvantages of this. And if you guys have any questions, I'm just trying to keep this super informal as well, like a hangout session. You guys can just interrupt me, ask me any questions if you have. I'll do my best to answer them. All right. So the advantages and disadvantages of open source development. One of the notable advantages is it forms, and this is from my own experience, it forms some sort of digital communities where since there's no like specific notion of who's bigger or who's better, although there are some maintainers, you get to have a chat, or some of these highly qualified people get to give you advice about your code base, let's say. Like for instance, I was making some changes in the Bitcoin, in one of the Bitcoin code, and then I got lots of advice from people who'd been working there for years. And that itself was such a motivating feeling, especially for a student, because you would want to get feedback, because you want to get better. So that something like that happens, and then automatically you start writing better code. Automatically you start forming better communities. And these communities, these guys aren't just like regular average people. These guys are fully like cryptographers, or some kind of PhD in certain field, and they're reviewing your code and giving you some feedback. So that was what stood out to me the most. Also, besides forming digital communities, you get heavily involved in highly reputed projects like Bitcoin, for instance, or React. It's open source as well, or Linux, or whatever it is. People don't just overshadow open source projects. A lot of companies actually value them, and they want to see more people get into it as well, because the amount of learning that you do is significant. And also third of all, like lastly, you make money while following passions. Most of the people that I've seen in the Bitcoin code base, people who make modifications, they've been there for almost a decade, for like pretty much a decade, since the beginning of Bitcoin till now. And then you can totally say that that's what their passion is, and that's what they follow. I'm not sure if they started making money beforehand, but eventually, when they got grants, or when they just like, yeah, mostly grants, um, they started making some money off of what they followed, and that is pretty significant in the society we're living in, which is very money centric. And it's a modern way to live life. Flexible hours, work from home. Obviously, because of COVID, we just started living life like this, especially people who work. But open source has been like this for years now. And then third of all, like lastly, you get to be your own boss. There's no one bigger. There's no one smaller. Obviously, you start with a small reputation. You got to build your reputation up. But there's no any boss trying to tell you what you should do and you shouldn't do. If you don't want to, you turn off your computer right away, and don't touch the code base for a week or two. No one will tell you anything. So you get to be your own boss, and that's where the idea of passion comes in. If you're passionate enough about that certain project, you will do it regardless of whatever the circumstance is. And obviously, there are major disadvantages to open source development as well. Obviously, first one being lack of monetary incentives, liabilities, warranties. Of course, for simple, small developers, like I didn't get paid to write any of the Bitcoin code, or a lot of people don't get paid. They just do it for the sake of learning, or just because it's fun and you want to get involved in these projects, or just to build up the community. So you don't get money, liabilities, there's no warranties, there's no health insurance, there's no company-wide like retirement plan or anything. So none of that is granted when you do open source projects. And it's also difficult to make a name for yourself, and lack of proper security. Yeah, it's pretty hard to actually get into some of these projects because it is so intricate, and learning the code base itself takes weeks of just grinding, and then lots of reading, lots of just studying that specific subject. So it's pretty hard to get into, but when you do, it's very addicting. It's like dopamine that's hitting you, and then sometimes it feels like it doesn't feel like assignment because it feels like a voluntary assignment. Like you can just not do it, but ultimately, if you want to, you would want to do it. So that's what it feels like towards the end. And then lack of proper security, meaning just the same. There's no liabilities, there's no warranties, and then you just have to make a name for yourself to go up and keep your reputation high up. So that's the some of the advantages, disadvantages of open source. Of course, these are some of the popular open source projects out there. Bitcoin being one of them, React, there's Linux, there's Firefox, there's GitHub. There's many more to come. Some of them are actually private as well. So it's company run. Of course, Google has lots of open source developers working on their specific open source projects. React from Facebook. So there are a bunch of like corporate open source projects as well. Now, the third philosophy is the main one, and this is what I want to talk to you guys about in this lecture, is how do you get going with Bitcoin open source development. So when you actually get into this code base, let's say you are someone who has taken fundamental decal and then have just started or just completed your dev decal from BAP, and then now you want to do more, let's say, blockchain heavy stuff, or you just want to get into Bitcoin, for instance. Like, what do? Do you just keep on learning more stuff, or is there a way you can just get into the code base? And this is where this lecture comes into play. This is where I will tell you, or I will instruct you what paths are available, possible paths to take. So the way Bitcoin open source development works is based on reviews, testing, and patches. So everyone who has done any kind of GitHub stuff, like opening pull request, and for those who do not know what pull request is, it's simply like, let's say there is an organization who has a project, then you would want to make some changes to that code base. So instead of making direct changes, you make a pull request so that other people working on that project could come in and review your pull request or your changes, and ultimately give you feedback. And once everything is ready and set up to go, they will merge it to the main code base. So it's simply like your contribution before it gets merged to the final code base. And then peer review ultimately comes in when people would want to give some feedback, give some advice to your code base or in your PR, and that's where reviews comes in for Bitcoin. Testing, there's different versions of testing that that someone would have to do. Let's say that's a P2P testing, peer-to-peer testing, or just testing this wallet functionalities, just to get an overall glance of how it runs in everyone's system. So that's the second thing. And then the patches is just like fixing errors and fixing bugs, or simply just like making PRs and giving out some contribution stuff. So those are the three forms. Obviously there are, like contributing to documentations and stuff would just go under patches. And second of all, there's no particular concept of Bitcoin developers in the sense of like privileged people. Like people who work in Bitcoin core, they don't classify themselves as privileged. They just love the project so much that they just want to contribute. They don't even want any form of label. So the concept of Bitcoin developers, like a senior developer or junior developer, is complete nonsense in the code base, and there's no such thing. But however, there has to be some level of hierarchy, because that should be maintained in order to enforce some kind of law or like regulations for practical uses, or else it'll be pretty hard to keep the system uptight and regulated. So there's the list of maintainers who are responsible for merging pull requests. So let's say you make a pull request, and this is your first pull request. You won't be a maintainer right away. You would have to earn some sort of level of reputation. Maybe that's like a certain number of PRs merged, or a certain number of reviews. And there are plenty of maintainers in the network, and then uh, those are responsible for merging the pull requests. And then there's lead maintainers is responsible for recycling release cycles as well as overall merging. So Bitcoin gives out updates in like these versions. So some of the mini versions, like the mini updates, will be passed into a big version. Um, so that's how lead maintainers actually kind of um, they're responsible for keeping those cycles updated. But basically, lead maintainers kind of have the same role um, to keep the network as fluent as possible and as free from any bugs as possible. So getting started real quick, this is the most important thing. And then if you're running Unix system, we can actually get started like right now as well. But before that, this is something that you can do without even having the code base. So if you know about Bitcoin enough, I bet you do know about UTXO models. I bet you do know about how the network operates. I bet you do know about Merkle trees, Merkle proofs, and I bet you do know a little bit about mining and how the mining process works, about like proof of work system. Then you are definitely eligible. You are definitely more than qualified to do some reviews in the Bitcoin network. So there's two forms of reviews that you can do. One of them is conceptual review and one of them is code review. There's the concept of ACK and NACK. ACK basically is a short form for acknowledge. So if you accept any, like let's say there's some form of concept that's being introduced, so that's called concept ACK, and then that ultimately means that I don't agree, or concept ACK means I agree with this concept and this implementation. Concept NAC means I don't agree with the general goal of this PR. So something like this, ACK and NAC, it's pretty self-explanatory. Let me know if you have questions on this though. And then the second form is called code review, meaning you have tested the code and it runs well, or you have pulled their PR and then made changes to it, tried a bunch of tests as well, and it works well. Nit changes are something that's like changing the way the variables are represented, or let's say, because Bitcoin uses snake case, so you use camel case instead of snake case, so that would be a nit change review. So something like those, something like minor type errors. And then also, I've not tested, but I have reviewed the code. Looks good. Something like that would be efficient as well. But what the pull the owner of the PRs actually want is very informative, and your intentions while reviewing should be, how can I break this PR? And this is what I learned the hard way, because when I went in, I always used to just get concept ACK because I thought it was cool. I thought everyone did it, so I was just like, I just used to put concept ACK. But then later on, I learned that your intention should be, how can you break this person's PR? Like, you have to be as rigorous as you can, as strict as you possibly can, and check pretty much every line of code that they write. So that's the intention you need to have while actually getting into the code base. So if you want to, this is the actual command line instructions that you can follow. This is for Unix system. If you're running, oh, sorry. So if you're running Windows, you would need to install Ubuntu, and then you need to do it through sudo. So you need to go through that, but I don't have the docs for that yet, and I'll definitely let you know. But this is for Unix, this is for Mac. If you want to do it, I can leave this up for a little bit. You have to clone the repo first, and then you just brew install all these packages and then configure. This will take about 30 minutes. And I'm pretty sure I'm going to have these slides up after the lecture as well, so you can just try it out in your free time. Okay. Or you can just take a picture of this right now and then try it out. And then let me know if you have any questions. And then git clone, the GitHub link is just look up Bitcoin GitHub. And then the first one that comes in, this is what the Bitcoin link should be. So you have to, oh, one thing that's not present here is you have to fork the repo and then clone it from your repo. So you don't clone it from the actual main repo. All right. So lastly, these are some links, helpful links that you can follow to get going with Bitcoin. And then finally, I want to take you guys on a tour of the Bitcoin code. We will go over a few specific details about how things are structured, like we'll look at Genesis block and stuff. So let's get right into it. So this is what the code base kind of looks like. It's a bit too heavy, but nothing to worry about, as you're just going to focus on one specific thing if you're really interested. So the first thing that I want to talk to you about is the chain params.cpp. Let me just zoom in a bit. So this is where the main blockchain is actually stored. This is where the creation of block happens. This is where all the settings are stored in chains. As you can also see at the top, Satoshi's there, and then from 2009 to 2020, this has been maintained by the developers. So the first thing I want to do is, or also, if you ever want to make your own blockchain, what you can do is you can fork this, and you have to make changes in this code base. So what people do is they make certain changes, like the way Genesis block is being is being formed. So you can make specific changes to chain params.cpp, because this is the pivotal point. This is like where all the settings are. So that's where it is. First thing that I want to talk about in this code base is, if you see here, this is the main network. Bitcoin has 3 different networks right now. So this is the main network. This is all the settings of the main network. And I will go over some of the settings in a bit. And then the second one is the test network. And then the third one is a regressional testing, which is the signet. Is it signet or regression? This is the regressional testing. We'll talk about signet later, because that's a more specific kind of testing. So mainnet is, of course, the real Bitcoin network. That's where all the blocks are being mined. That's where all the coins are stored. That's where everything happens. So this is the mainnet configurations. There's the test net, where basic test happens. Like if someone wants to release a feature, for instance, I don't want to introduce a lot of terminologies, but I hope you've heard of SegWit. So while introducing SegWit, they had to put it in testnet first and then the mainnet. That's pretty much the same with all the blockchains. They do have some sort of testnet to test it on. And then finally, what you have is you have regressional test. What regressional test means, and what the difference between testnet and regression test is, let's say you want to test what happens to your chain, what happens to the blockchain if 1,000 blocks are mined. So in a testnet, you would actually have to wait that certain amount of time until 1,000 blocks are mined, because this is actually a real chain, and people run this as like they run the nodes and stuff. But for regressional testing, you can generate those 1,000 blocks instantaneously and then see what happens in those tests. So that's why it's pretty popular. Like regressional testing, people use it most of the time when they're dealing with things that requires a significant amount of time. So those are the 3 tests to keep in mind, and that's under src/chain params. You can actually follow me if you don't even have the code base. You can go to github.com and then like GitHub Bitcoin, and I'll show you where that specific file is. So you can go to src and then look up chain params. So this chain params at CPP. Then this is where all the code that I just talked about is. So there you go, mainnet and then testnet and stuff. Yep. And then now what I wanted to talk to you about is called these 2 values. These 2 values are super important. Um, just talk about in mainnet because it's pretty much the same in testnet as well. Yeah, pretty much the same. So uh, what n power target timestamp is that it is how often the network adjusts its difficulty to compensate for the change in hash rate. That was a very long and broad statement, but it's basically how the network changes its difficulty based on how fast the blocks are being mined or how easy it is for the block to be mined. And in the Bitcoin network, there is no dependency on like the time that we're so accustomed to. So it's not like it's like 640 right now. Bitcoin, the system, the blockchain system that Bitcoin uses, they don't know about like 4/8 2021 or it's 640 right now. None of that. So the way time is being determined is based on how many blocks are being mined after this current block. For instance, a block has to be mined every 10 minutes. That's the law, that's the consensus rule, right? And then after every 2 weeks, 2 weeks, meaning if you mine a block every 10 minutes, then after 2 weeks, you're going to have 2016 blocks that will be mined. So after every 2016 blocks that's being mined, the difficulty changes. So this is where that 2 weeks period comes into play. So that's where they define it. What other cryptocurrencies do is they fork this and then they basically change this so that they can adjust the network difficulty faster than 2 weeks or even later than 2 weeks. So this is why it's so important, and this is very critical in the Bitcoin network. The second of all is the NPOW target spacing, and this is when this basically means that how often a block has to be mined, and this is currently set to 10 minutes. Let me check my slide. So this is how often a block has to be mined, and right now it's 10 times 60, like 60 seconds, so it's 10 minutes. So that's what it is. So those two are pretty important. And then let's see what else is there. So right here, this is the Genesis block that is very infamous. It reads what Satoshi wrote, the Times 03 Jan 2009, Chancellor on the brink of second bailout for banks. These are actually something that's present within the code base. And what's so special about this Genesis block is that it doesn't have any input, okay? Because you get the Genesis block, it only has output. Oh, I think that's the code base. No. The Genesis block is the first block that only has output as well, exactly, because there's no input. So what's also interesting about why Satoshi actually decided to write the specific date and then code the magazine itself is, as I mentioned before, there is no real definition of time in blocks in like the Bitcoin system. So when he codes the time 2009, January 03, this is like a proof saying that this is when he actually created the Genesis block, because he couldn't have done this before this time, or else the newspaper headline would have been something else. This is on the specific day. If you look this up, you will find the magazine as well. You find the newspaper, and you can say this is on the specific day that he actually made the Genesis block, or maybe later, but he didn't do it before this day. So when there's no notion of time, what can happen is, let's say I can make my own blockchain, I can mine a lot of coins and then make it public. So before actually even having public access, I'm gonna have a lot of coins, and if it blows up, then let's say I make a lot of money, which is really not fair. So Satoshi actually wanted to have a system like this, or like actually embed the time frame so that people would know when this was created, when he actually like I can have a bound set of when the Genesis block was actually created. So that's what's so special about this. And then second of all is, let's look at halving. Okay, right here. So I want to talk to you about this as well. And these are some of the implementation consensus details, which is very important. So I hope you've heard about Bitcoin halving halving it just Bitcoin halves every 4 years, and then that basically means the block reward splits in half. So at the beginning it was 50, 25. I believe right now it's like 6 point something. So since it doesn't have an accurate representation of time frame, this is the number of blocks. So this is the number of blocks, blocks number when the network triggers halving. So from the beginning of the block, after 210,000 block has been mined, the block reward halves, and then this is set to 0. And then after 210,000, oh, you don't even have to say it, you just multiply it by 2. But after the next 210,000 blocks, the network the block reward halves again. And then that's why it's so important that it's not like time-based system. It doesn't have a reference about years and months and seconds or minutes. It has a reference about the block, how many blocks have been mined since the beginning. And then also what's so special about this is, let's look at amount, amount.h. And this is where the limited supply of Bitcoin comes in. And this was specified by Satoshi himself that there can only be 21 million Bitcoin available. This is where the limited supply comes in. And this has been actually said. It's constant, so you can't change it. Static, meaning can be any like form of object, I believe. And then coin, this is just in Satoshis, meaning it's 8 zeros. So this is represented in Satoshis. So that's what's so cool about this, that everything that you've learned, you can see it in code now. So you learn that there's a limited supply of Bitcoin, which is 21 million. You can actually see it in code. It's true. It's not like a fancy fiction that someone's telling you can't actually see it. And this is the real code base that is being trusted, and it's been used for a decade now. So that's what's so amazing about this. And then finally, what I wanted to show you guys about, just to give a glance of the code base, is, let's see, just pick up my notes. All right, let's look up miners.
Excuse me, could you explain the halving again?
Oh yeah, totally. So at the beginning, when Bitcoin was introduced, let's say 2009, the block reward was 50 block rewards. Like after you mine a block, the miner would get 50 Bitcoins in return, right? So after every 4 years, the network reward halves. So that, like, let's say it was in 2010, the network reward was, the block reward was 50. In 2014, it would be 25. And then after every 4 years, the block reward halves. And I believe the reason behind that is just, is of course there's a limited supply. And I think it falls under, like, there's a limited supply of Bitcoins and you can't have an infinite supply. So there has to be a limited amount of block rewards that is processed. And then the way block rewards, because since I told you that Bitcoin doesn't keep track of time as humans do, like it doesn't have any reference of years or seconds or dates or months. The way it decides when to have is whenever the 210,000 blocks has been mined, then the block reward halves. So at the beginning, let's say it was 0, and then 210 blocks have been mined, then the block reward goes from 50 to 25. And then after 25, it waits until the next 210,000 blocks have been mined, and then the reward halves from like 25 to 12.5. So that's how it goes until it's like pretty close to 0. Obviously, towards 0, it goes in an asymptotic pattern, so it will never reach like completely 0, but I think they're expected around like 2140. That's when the Bitcoin network, the mining reward will like pretty much be obsolete. So did that make sense?
Yeah, thank you.
Yeah, no problem. Okay, and then the next one, this is also regarding mining. And then what's so cool about Bitcoin is all this system was put in place before, The only reason why Bitcoin blew up, because there was other systems before this, like DigiCash, Hashcash, others. Pretty sure you guys have learned this. But why this blew up was this mechanism of decentralization, like proof of work. Like Bitcoin was the only one who did proof of work with digital currencies. That's why it is so widely recognized right now. So I want to go over this code right here, which is called create Coinbase transaction. And then this basically means that whenever a miner mines a block, they get a mining reward, right? Let's say the mining reward is 50. So I mine a block has a bunch of transactions. I verify those transactions using proof of work. I get the nonce. Whenever I hash it, the nonce is accurate, and then I mine that block. So what happens is I get my block reward. The block reward has no input but one output. One output is set to my wallet address, and then that's how I receive that address. That first transaction that I get from that Bitcoin is called the Coinbase transaction. And Coinbase transaction doesn't have any input because no one is sending it to me. The network itself is given the Bitcoin to me. So that's why it's called the Coinbase transaction. And here's what's so important. You don't have to know this, but this is just a general thing. And just for reference, a miner has to wait until 100 more blocks are being mined since that block reward to actually use the block reward that they received. So let's say I got a block reward for my for the 100th block that I mined. So I'm gonna have to wait till the 100th other block that's being mined to actually use that Bitcoin. And that is just a consensus rule to prevent any form of like double spending and stuff. So that's something that's important. And then finally, now that we've gone over Codebase, I will show you what I've been up to in the Codebase. So I have opened a couple of PRs, and this is what I'm working on right now. It's just called mempool limit pi even when wallet is disabled. I'll give you a quick overall overview of what it actually does, and that'll probably be it for today's lecture. So this is how you open a PR. Like you have a PR, and then there's a bunch of people who view your PR. And then you get a bunch of reviews, you fix your code, like these are pending reviews that I still need to update, and then you just fix your code and keep pushing it to your branch. So I'll show you what it actually does. So it's mempool limit. So mempool in Bitcoin is whenever you make a transaction, let's say I want to send a transaction to Solomon. Whatever my wallet has like private and public keys, whenever all the verification process is done, my transaction goes to these nodes. There's a bunch of nodes. That's how the system is decentralized. So my transaction goes to one of these nodes, all right? And anyone can host these nodes. Like I can host these nodes, Solomon can host these nodes. They just have to have the entire copy of the Bitcoin network. From the very beginning. So they have to have all the UTXOs, all the transaction history, all the blocks, everything should be within that node. That's why, that's how you can host a node. Basically, it's like a constant update of what's happening in the network. That's what hosting a node basically means. So let's say I will make a transaction to Solomon. Let's say I want to send one Bitcoin to Solomon. I enter Solomon's like Bitcoin address, and I click send. What happens after that is my transaction goes to these nodes. These nodes have a certain amount of RAM in their computer space. That's where my transaction sits, okay? So my transaction sits there for a little while, and obviously the first confirmation takes around 10 minutes for any Bitcoin transaction. So I wait. So my transaction goes in this some random person's nodes RAM, and then they kind of like gossip with other nodes. So nodes automatically gossip with other nodes, and that's how my transaction is being transferred to multiple nodes. And when it's being transferred to multiple nodes, what miner can see that a transaction is being processed. So what they're going to do is whenever they're ready, whenever they want to mine a block, they're going to pick these transactions from these nodes as mempool. memory pool. Mempool basically means a memory pool. And the reason why it's called memory pool is because the transactions are stored in RAM. RAM is like a memory. It's where like memory store. So miners actually pick these transactions from node's memory pool, and then that's how they mine that block with mine those transact like they basically mine the block with the transaction in them. So that's how the process of mining works. So whenever I send the Bitcoin to Solomon, the nodes get my transaction and they store it in their mempool, and then the miner receives the transaction. Whenever the block is mined, Solomon will be notified, or I'll be notified that this is the first confirmation. After the first block has been mined, that's the first confirmation. And when that block is being chained up with another block, that's the second confirmation. When there's a third block, that's the third confirmation, and then it's pretty good to wait until sixth confirmation, which takes around an hour. It's very slow, but there are things being done to improve this. So what my thing does is this is called mempool limit. So I will actually run you guys through it. Let's try to make it pretty quick. So I hope I believe you guys know about UTXOs and how they work. All the inputs should equal outputs, right? And then if you're not sending, like, everything has to be spent whenever you make a transaction. So the rest is just going to be sent to my own address. So what I'm going to do is, this is just a test. So Bitcoin has functional test and unit test. So this is not like directly interacting with the main code yet. This is just writing like a little code for certain functions to run. So this is just like checking if the mempool will have enough transactions or not, or how would they even interact with each other. So here's what's going to happen. So I'm going to run you through from here. So this is a node. I just declare a node. I can just do this pretty simply in Bitcoin, like self.nodes. Relay fee, mempool fee, just hold that for a minute. Relay fee, it's just like when mempools try to gossip with other nodes, there's like a certain fee that your transaction have to meet so they could relay. That's basically what it means, but don't think too much, don't overthink it. But this is important. Mempool min fee is actually very important. That's the minimum amount of fee that you can send over your transactions so that you can guarantee that your transaction will be mined. Of course, you can send zero fees and your transaction will still get mined, but that would have very, very less chance of getting mined, because you have to understand from miners' perspective as well that they want to pick the transaction with highest fees, right? Because they get the transaction fees as well. So you always want to average out your fees to be like pretty much the market fee. So right now the market fee is around like 0.0001. That's like kind of known as the default fee, but you can just set it to 0 as well. So we're checking if the mempool min fee, which is where my transaction will be stored, is actually equal to this. Okay, and then this is just an array, transaction array. Just ignore this from now on. And just remember that this is a way to generate UTXOs. And the way this is happening is there's a separate class called wallet.py, and this is where I'm getting the UTXOs from. And the UTXOs are just being generated like this. We're just appending in a UTXO transaction ID of, or like, and then the V out value, and then like V out and then value and stuff. So just like kind of ignore that for now. And just remember that this is a way to generate UTXOs. And then we're generating 92 UTXOs. However, we are also doing this because we want to make sure that these UTXOs are spendable. And the only way these UTXOs are spendable is if 100 more confirmations are made. So this is where the 100 other confirmations are being made here, node.generate. So that's what's happening. So the premise of this test is we have a mempool. Let me know if you have any questions on the mempool right now, right? Because things are about to get a little bit complicated, but I'll try to run you guys through it. So we have a mempool. What we're going to do is we're going to send a transaction to the mempool, all right? So quite simple. We're going to send a transaction with this much fee, which is 0.0001. It goes to the mempool, it sits in the mempool until a miner comes in and takes the transaction to mine. So now what we're going to do is we create that transaction right here. All right, so we create the transaction, we send the transaction. If you want to know what this is doing, send self-transfer, it's in wallet.py, and then it's basically like setting up UTXOs and creating a transaction, and then ultimately just like sending the transaction, right? So it's just sending the transaction to the mempool. That's what's happening. So now what we're going to do is we are now going to flood this mempool with, let's say, bunch of other transactions whose fee is higher than the fee that we inserted at the very beginning, or like inserted in our first transaction. So guess what's going to happen after that? So what's going to happen is that our fee at the very beginning, the transaction with the fee at the very beginning, will get evicted because the mempool min fee has gone up now. So I'll actually show you what that looks like. So let me print out no.get mempool info. So this is when we're getting the information about the mempool before we actually make this transaction. And this is when this is where we have the default mempool fee of 0.0001. And that's the fee that we use here. After this, what's going to happen is we're going to check the mempool again, and the fee is going to go up. Check this out. So print no.get mempool info. So now if we log these values, let's check this out. So what's going to happen is the total fee is obviously 0e to the power negative 8, super low. Now what happened is the fee went up, okay? The fee actually went up to 0.1488. As you can see, the size of the transit mempool has changed, the bytes in it has changed, the uses has changed, and then the way Bitcoin's transaction fee is determined is not based on how much value you're transacting. It's based on how big your transaction is. So if the bytes are this big, the fee is going to be big as well. So that's what I wanted to tell you guys. So now what's going to happen is this transaction is going to get evicted, and that's what we're doing right down here with this logic. So right here with this logic, we're trying to check if this transaction is present in the mempool or not, which clearly isn't. I mean, we can actually log these values out, like no.get raw mempool. So let's log these values out before and after. No, let's just do it after we create the first transaction. So there you go. That's our first transaction that we made that goes to the mempool. This is actually a transaction in the mempool. And then now you can see all these other transactions have been made with higher fees, and then our mempool just gets evicted. So that's the test that I'm doing here, which is pretty straightforward. It just tests a certain behavior in mempool, and then it outputs whatever needs to be outputted. And then later on, this final test is just simply checking if we can make the transaction with this minimum fee again, which we can't, because the minimum fee of mempool has increased now, which is like 0.11 something, 14 something. So that's one of the functionalities that I'm testing, and which is super cool, guys. Like, this is something that you just learn in books or decals, and you actually get to do these stuffs, which is amazing. So that's one of two PRs that I'm working on, which is pretty cool. And that's mostly it, guys. I wanted to keep it short, keep it within an hour. Let me know if you have any questions right now. If not, it's pretty much it, unless Solomon, Nathan, you guys have anything else?
Yeah, so I'd highly recommend doing open source development. I think that it's a really fantastic way to gain some experience, especially in like a really novel industry such as blockchain. I myself have started looking into the code base of Cosmos to do some open source development. But one question I had when I was starting out, and I'm sure many people might have, is like, say I want to start on open source development at a given library, and I look through the set of issues that are like, of course, whenever you're working on open source development, you're usually implementing a feature that's laid out in the issues. But what would I like? Would I be able to access, like, tap into the resources that are the resources of other developers if I wanted to get started? Like, what is the process of saying, like, okay, I got this issue, I'm going to work on it. What do I need to do?
Yeah. So that's where I struggled as well at the beginning, because it's very hard to get into these issues unless you have been following all the PRs and everything has been like very well. And there are a bunch of issues you can just follow through in Bitcoin as well. However, this is a special time where what's happened is, um, I'll just give you a little bit of intro on what's happening. So a while ago, this developer called Marco, he made this open PR, which is just like a good first issue as well. And this is just in the Bitcoin network as of now, that there needs to be a lot of refactoring. So before, what used to happen was, so there used to be a bunch of test cases. So let's do skip. Let's say, so in Bitcoin, what used to happen is some of these tests would not function if there was no wallet present. So you had to compile the wallet first and then run these tests. But now what Marco has proposed is there's actually another way to make these functional tests to run, which is called the mini wallet. And my mempool limit is actually a refactoring of mini wallet as well. And then you can do refactoring in pretty much all these tests. Like these are all available tests right now. And then I actually have a Bitcoin open source thing. We do it every Friday from like 3 to 4. We actually go over one of these PRs, and then we have like 4 or 5 people, and then we actually go over specific PRs. Let me know if you want to do that or anything. Happy to take anyone. Um, so this is like the easiest way to get into this code base, and especially to test, you learn so much about the actual code base that after doing like 3 or 4 tests, you would be so well, so solidified in that certain aspect. Like let's say you do 3 of mempool functionalities, you do mempool limit, mempool persist, and let's say mempool like accept or whatever it is, then you would know so much about mempool that you could just get into the code base and then would be able to make some pretty big changes right away as well. So I would just recommend going through code bases, going through test. If you're interested, these are available PRs right here. Like these are available issues, you just need refactoring. So this is a special point in time. Like this didn't happen to me last year. Like last year, I just had to fetch through issues, fetch through PRs, and read every people's comments and actually figure out how I can contribute. But this time, it's pretty much open. Outside of this, what Bitcoin also has to encourage new developers is they have these tags. One of this is called good first issue or good first review. Well, it's kind of closed right now, but they have it updated every once in a while. And then if you go down and just click good first issue, one of them just closed. Then these would be some of the good issues that could be done by any new developers that just got in. And people are really nice. They'll help you like in pretty much every step. So that's why it's so special as well. Yep.
Cool. Thanks to share. Also, there are a couple questions in the chat if you want.
Oh yeah.
To address those.
Is blockstream drama still going on at Bitcoin Core? What was the drama? Is it a recent one? The biggest drama that went on was in like 2017 when the network forked, like Bitcoin Cash forked from Bitcoin. Besides that, I think there's just internal drama that always happens. And then the next thing is regression testing. I believe I went over this, but regression testing is just like you want to get the blocks instantaneously. Like sometimes the network takes a long time to actually do that certain testing. Let's say you want to test what happens to the network after 1,000 blocks, you would have to wait in the test net until 1,000 blocks have been mined. And regression testing can just do it instantaneously. Anything else?
I think that's it. Thanks once again, Sashir. I will. I guess we can stay on for a couple minutes. I'm just
Yeah.
gonna stop the recording.